Welcome to this deep dive. You know how it is, you're looking to get smart on something new, maybe really understand the core ideas without getting bogged down in jargon or endless pages of research.
Right. You want the essence, the stuff that matters.
That's precisely what we're doing for you today. We're taking a fascinating, pretty recent study in educational psychology and pulling out the nuggets that really count. Specifically, we're looking at how learning in virtual reality, VR,
Yeah,
how that impacts your ability to actually apply that knowledge in the real world.
exactly. And the source we've got for you is solid. It's a study published just last October, 2024, in the Educational Psychology Review.
Okay.
The title is, Does Embodiment in Virtual Reality Boost Learning Transfer? Testing an Immersion Interactivity Framework. So this isn't just like an opinion piece.
Right, it's peer-reviewed,
Yeah.
checked by other experts.
Precisely. Rigorous stuff.
And the mission, our mission for this deep dive, is really to understand whether learning a practical skill, and the researchers here looked at pipetting, that precise lab technique.
Yeah, tricky little thing.
Is it learned more effectively in VR
Mhm.
when the whole experience feels incredibly real, really interactive? But maybe even more importantly, does that learning actually transfer? Can you take what you practiced in VR and then do it just as well with like actual physical pipettes and stuff?
That's the fundamental question for any learning experience, isn't it? Does it work outside the classroom, or in this case, outside the headset?
Exactly.
And the researchers were laser focused on this idea of transfer, your ability to take what you learned in, say, the virtual lab and apply it effectively in a new situation, like the real lab. It's not just remembering facts, it's about using the knowledge flexibly.
All right.
And what's really interesting here is the angle they took. They examined this through what they called an immersion interactivity framework.
Okay, this immersion interactivity framework sounds pretty central. Can we maybe unpack that a bit so we all understand what the researchers were really looking at?
Yeah, absolutely. Let's break it down. They essentially created 4 different learning situations
Okay.
by changing up 2 main things: immersion and interactivity.
Immersion and interactivity. Got it. So immersion first.
Right. For immersion, they compared learning inside a fully immersive VR setup, wearing a headset,
Right. Totally surrounded by the virtual world.
versus learning the exact same stuff, but just on a regular computer screen, a standard PC monitor.
Okay. So one group felt like they were really in the virtual lab. The other was sort of looking at it through a window, basically.
That's a good way to put it. A big difference in that feeling of presence.
Okay. That makes sense for immersion.
Yeah.
And what about interactivity? How did they fiddle with that?
So for interactivity, they looked at how learners actually handled the virtual tools, like the pipette. In one set of conditions, people directly manipulated the virtual pipette and other instruments. So using the VR controllers or, a mouse and keyboard on the PC.
Okay, like mimicking the hand movements.
Exactly. They called this congruent interaction because the actions you did virtually were meant to mirror the real-world movements needed for pipetting.
Congruent, okay? And the other way?
The other way was incidental interaction. So instead of direct manipulation, learners use something like a laser pointer in VR.
Oh, like point and click.
Yeah, or just clicking the mouse on the PC version to select actions. The gestures themselves weren't really analogous to the physical act of pipetting, more indirect.
Okay, let me see if I got this. So we got this sort of 2x2 setup, right?
Exactly.
High immersion with VR versus lower immersion with a PC screen. And then for each of those, you've got high interactivity, the direct hand movements versus lower interactivity, the pointing and clicking.
You got it. That setup really lets them test how these different levels of sort of virtual embodiment might play out for learning and transfer.
Right. And you hinted earlier there were some maybe surprising findings. What
Right.
stood out?
Well, here's where it gets really interesting. The groups who learned in VR, they definitely felt more embodied.
Okay, that makes sense.
Yeah, they reported feeling a greater sense of presence, more agency, like they were controlling things, even a feeling of like ownership over their virtual hands, all the stuff you'd expect from VR.
More immersed?
But, and this is the kicker,
Yeah.
this stronger feeling didn't actually translate into better performance when they had to do the real pipetting task later.
Wait, really? So all that fancy VR tech making it feel more real, it didn't actually give them an edge when they picked up a real pipette?
Nope, no statistically significant difference.
Wow. That kind of goes against the grain, doesn't it? You just assume that a more realistic simulation would lead to better real-world skills.
You would think so, wouldn't you? It really challenges that intuitive idea. It suggests maybe that feeling of being there in VR while it changes the experience subjectively.
Hmm.
It wasn't enough, at least in this specific case, with this skill to produce, superior skill learning that you could then just apply easily in the physical world.
Huh. Any thoughts on why that might be? Did the researchers speculate?
Well, one possibility they raise is about proprioceptive feedback, that sort of ingrained sense of where your body parts are and how they're moving.
Like the feel of it.
Exactly. That feedback is still fundamentally different in VR, even with good controllers. It's not quite the same as holding a real object, feeling its weight, its resistance.
Right. Subtle differences.
And for a fine motor skill like pipetting, maybe those subtle cues are more critical than the visual realism VR provides right now.
That's a really key insight. So just feeling more immersed isn't the whole story for transferring physical skills? Okay, what about the other factor, interactivity?
Mm-hmm.
Did the way they interacted, direct versus pointer, make any difference in the real world?
Also, interestingly, no. The study found that whether students use the direct manipulation method or the laser pointer click method, it didn't significantly change how well they did on the real-life pipetting task either.
So neither the immersion level nor the type of interaction in the simulation seemed to give a clear boost for the real-world skill.
In this specific study, for this specific task, yes. That seems to be the finding.
That really makes you reconsider things, doesn't it? The whole assumption that, more realistic, more interactive VR is always going to be better for learning schools that need transfer. It feels, a bit counterintuitive.
It does. You naturally think more real equals better learning. But this study suggests the connection, especially for certain technical skills, might be more complicated than that. It kind of pushes us to think more critically about what specific parts of a learning experience are actually driving the skill improvement and the transfer. Is it just the tech or something else?
But, the study wasn't a total wash for VR, was it? Did they find anything positive or, otherwise interesting beyond these kind of null results on immersion and interactivity?
Oh, yeah, absolutely. They did uncover something quite intriguing, actually.
Okay.
They noticed that how well the students performed during the virtual lesson itself.
Inside the simulation.
Yes, inside the simulation didn't matter if it was VR or PC. That performance was actually a pretty good predictor of how well they do later on the real-life transfer task.
Okay. So if you did well in the practice, virtual or otherwise, you tended to do well in the real test.
Exactly. If you made fewer errors, were more efficient during the virtual practice, you were more likely to perform better when you handled the actual physical pipette.
Well, that makes a certain amount of sense, doesn't it? Practice matters.
It does. It suggests that even if the VR environment doesn't perfectly mimic reality in ways that boost transfer directly,
Right.
the act of practicing the steps, getting the procedure right, receiving feedback within that virtual environment that still hold value.
So the core learning process, paying attention, making mistakes, correcting them, that's still fundamental, regardless of whether you're wearing a headset or looking at a screen.
Precisely. It underscores that you can't just rely on fancy tech. You still need focused practice and, learning from errors to really build a skill effectively. The medium matters, but maybe not as much as the quality of the practice itself.
Okay, that's a really useful clarification. So, given these findings, VR feels more real but doesn't automatically boost transfer. Interactivity type didn't matter much here, but practice within the simulation did. Where do the researchers suggest we go from here? What needs more looking into?
Well, they point to a few key areas for future work. One big one is the need for better VR interaction technology.
Better tech, like what?
They specifically mention hand tracking. In this study, even the direct manipulation used controllers, right? Which still aren't quite the same as using your bare hand.
Right, you're holding a controller, not the virtual object itself directly.
Exactly. They propose that as VR tech gets better, maybe with more seamless, natural hand tracking, the impact on learning transfer might actually change, might be different.
That makes sense. If the virtual interaction itself is clumsy or feels unnatural, maybe that gets in the way of learning the actual skills smoothly.
Could be. Better, more intuitive interaction might create a stronger link between the virtual practice and the real-world movements. It's a potential limitation of current tech that might be influencing these results.
Okay, so tech improvements is one avenue. What else?
They also really stress the need to explore these questions with different kinds of learning tasks and in different groups of people.
Right, pipetting is just one skill.
Exactly. It's a specific technical motor skill.
Right.
Would these same results hold up if you were learning, say, a complex decision-making process, or maybe something involving spatial reasoning?
Or maybe even like interpersonal skills simulations.
Potentially.
Yeah.
Or what about different age groups? Or people with different levels of prior experience with the task? Or with VR itself? There are lots of variables.
So basically, don't generalize too broadly from this one study. We need more research across different contexts.
That's the responsible scientific approach, yes.
Mm-hmm.
Build the picture piece by piece.
So thinking about that tech evolution point,
Mm-hmm.
if VR does keep getting better, more sophisticated, more natural interactions, could these findings change down the line? Is it possible we just haven't unlocked VR's full potential for this kind of learning yet?
That's a very astute point. It's entirely possible. What we call high immersion or high interactivity today might seem pretty basic in, say, 5 or 10 years.
Right.
As the technology matures, becomes more seamless, maybe remove some of those friction points we talked about, its ability to genuinely enhance learning transfer could definitely evolve. This study gives us a valuable snapshot in time, a baseline.
Okay. This has been really illuminating, a good deep dive into the specific piece of research. So just to try and wrap it up concisely for everyone listening, the main takeaway seems to be, while VR definitely makes the learning feel more present, more embodied,
Yes, the subjective experience is stronger.
this particular study didn't find that it automatically led to better transfer of a technical skill, like pipetting, to the real world, at least compared to learning on a regular computer screen.
Correct. That link wasn't evident here.
And also, the specific way students interacted in VR, direct versus pointer, that didn't seem to make a significant difference to their real-world performance either in this case.
Right. Both interaction types led to similar outcomes on the transfer task.
However, and this is important, how well someone performed during the virtual lesson, whether it was VR or PC, that did predict how well they'd likely do with the real equipment. So practice and performance within the learning environment itself still really counts.
Absolutely. That engagement and mastery during practice seems key, regardless of the platform's bells and whistles.
And the researchers are pointing towards needing better VR interaction tech, like hand tracking, and needing to test this across more skills in people.
Yep. Those are the key future directions they highlighted.
So this study really makes you kind of question that easy assumption, doesn't it? That the super immersive interactive learning is always just better for outcomes.
It does. It suggests the relationship between the feel of learning and the actual effectiveness of learning, especially for transfer, is maybe more complex than we think.
Which leads to maybe a final thought for people to mull over.
Yeah.
Where might VR's strengths lie more definitively? Are there other areas of learning, maybe less about fine motor skills, where that immersion could be a much bigger advantage? Or maybe areas where it's less relevant?
That's a great question to leave people with. You know, think about learning complex spatial layouts, or experiencing historical sites, or practicing responses in dangerous scenarios.
Right, things impossible or impractical to do in reality.
Exactly. Could VR be much more impactful there? Or perhaps for learners who struggle with traditional methods. It forces us to think about why and when VR might be the best tool, not just assuming it always is.
Definitely food for thought. How might these findings apply to your own field, your own learning? Something to ponder. Well, thank you for joining me for this deep dive.
My pleasure.
Until our next exploration.